It's 2:47 a.m. Pager duty fires. A senior SRE wakes up, logs into 5 different dashboards, correlates logs manually, identifies a memory leak in a payment service, rolls back the deployment, and verifies recovery. Total time, 47 minutes. Customer impact, 12,000 failed transactions. This happens 3 to 4 times per week at the average enterprise. The cost isn't just downtime, it's engineer burnout, customer churn, and SLA penalties. What if the entire sequence, detect, diagnose, remediate, verify, happened in under 4 minutes with zero human intervention? Zero-touch incident response follows a closed loop. Observability data flows continuously into the AI agent, metrics, logs, traces, and deployment events. When anomaly detection triggers, the agent doesn't page a human first. It correlates signals across data sources, identifies the most probable root cause, selects a remediation action from its playbook, executes the fix, and verifies recovery through health checks. Only if automated remediation fails does it escalate to a human with a full incident report, timeline, and recommended actions already prepared. The human becomes the exception handler, not the first responder. Traditional alerting is broken. Static thresholds generate noise, CPU above 80% doesn't mean incident. During a deployment, 20 alerts fire simultaneously and the on-call engineer plays whack-a-mole. AI detection works differently. It learns normal behavior patterns for every service, traffic volume, error rates, latency distributions, resource usage, and detects anomalies relative to those patterns. A sudden spike in 5xx errors after a deployment is correlated with the deployment event automatically. Instead of 20 alerts, the agent generates one actionable incident with root cause attached. Signal, not noise. Root cause analysis is where AI agents save the most time. A human SRE correlates data across tools, checking deployment history, scanning error logs, reviewing metric dashboards, tracing request flows. Average human RCA time, 18 to 34 minutes. The AI agent does this in seconds. It has a graph model of your service dependencies. When errors spike in the payment API, it traces upstream to the auth service, downstream to the database, and sideways to recent deployments. In our benchmark, agents identified root cause correctly 87% of the time on first attempt, compared to 72% for human SREs under alert pressure. Remediation playbooks are the agent's action library. Rollback deployment, triggered when errors correlate with a recent deploy, success rate 94%. Restart pod, triggered when a single pod shows anomalous behavior, success rate 91%. Scale horizontally, triggered when latency spikes with increasing traffic, success rate 88%. Failover to secondary region, triggered when primary region health checks fail, success rate 96%. Block traffic to failing service, triggered when cascading failures detected, success rate 97%. Each playbook has preconditions, execution steps, and verification checks. The agent selects the playbook whose preconditions match the current incident signature. Here's a real incident from last month. 2:47 a.m., anomaly detected in payment service, error rate 0.3% to 4.7% in 90 seconds. 2:47:12, agent completes RCA, memory leak in version 2.3.1, deployed at 2:33 a.m. 2:48:30, agent initiates rollback to version 2.3.0. 2:49:45, health checks pass, error rate back to 0.2%. 2:50 a.m., incident report generated and posted to Slack. Timeline, root cause, remediation action, impact assessment. Total resolution time, 3 minutes. Zero human intervention. The on-call engineer read the report at 8 a.m. with coffee, not panic. AI agents don't replace SREs, they handle the routine so SREs focus on the complex. Escalation triggers include: remediation playbook fails after 2 attempts, incident involves data integrity risk, security-related anomaly detected, multi-service cascading failure beyond agent's dependency graph, or any incident tagged P0 by policy regardless of auto-remediation success. In these cases, the agent escalates with full context, not a bare alert, but a complete incident brief. The SRE starts at minute 5 with a diagnosis, not at minute 0 with a pager and 5 dashboards. Building your playbook library starts with history. Pull your last 90 days of incidents from PagerDuty or OpsGenie. Categorize by root cause, deployment regression, resource exhaustion, dependency failure, configuration drift, external service outage. For each category, document the remediation steps your team actually took. Encode those steps as agent playbooks. Test every playbook in staging by injecting the failure mode and verifying auto-remediation. Start with your top 3 incident categories, they typically cover 60 to 70% of all incidents. Expand the library monthly based on new incident patterns. Track these metrics to prove ROI. Mean time to resolution, our benchmark teams went from 47 minutes average to 3.8 minutes, 92% improvement. Percentage of incidents resolved without human intervention, 73% average across teams with mature playbook libraries. False positive rate, agents must not remediate when there's no real incident target below 2%. Engineer pages per week, dropped from 12 to 3.5, a 71% reduction in interrupted sleep. Customer-facing SLA compliance, improved from 94.2 to 99.7%. These numbers justify the investment to any leadership team. Zero-touch incident response isn't science fiction, it's running in production at companies you know, resolving incidents in minutes instead of hours, 3 a.m. instead of human SREs. Start by analyzing your incident history. Build 3 playbooks. Deploy an AI agent in detect and recommend mode before enabling auto-remediation. Measure for 30 days. Then let the agent handle the routine while your SREs engineer reliability instead of firefighting. I'm AI DevOps Daily. Next episode, we explore replacing Ansible with AI for configuration management in 2026.